Hello friends, we deal with partial differentiation. Okay, area of a rectangle. You have studied about the area of a rectangle, right? Area of a rectangle, which depends upon length and breadth. That is, area as a function of two variables. That's its length and breadth. Z is called a function of two variables, x and y. If z has one definite value for every pair of values of x and y, that is z equal to f of x, y. The variable x and y are said to be independent variables. That is, they are free to vary, and z is called dependent variables. That depends upon the values of the variables x and y. That is the definition for a two variable function of two variable. Okay, area of a rectangle means it depends upon length and breadth, and area is a function of two variables, a length and breadth. Area can be seen as a function of both length and breadth. Similarly, any function means z is called a function of two variables x and y if z has one definite value for every pair of values of x and y, then z equal to f of x, y, where x and y are said to be the independent variables and z is the dependent variable. What is the geometrical interpretation here? That z equal to f of x, y, where xy belongs to an area A of the xy plane or coordinate axis. For every ordered pair xy corresponds a value of z. These values of ordered triplet xyz, it forms a surface in space, and hence the function z equal to f of xy represents a surface. Then what about the limit of such functions of two variables? Limit. The function fxy is said to tend to the limit L as extending to A and y tending to B if and only if the limit L is independent of the path followed by the point xy is extending to A and y tending to B. After the mathematical explanation, it will be more clear. Limit extending to A, y tending to B, f x y equal to L. Irrespective of any path, we can approach a point AB from both directions or from any sides, from any paths, through any paths like y equal to mx or y equal to some mx square. Through any path we can approach the function f of xy, but here the limit L, which is independent of the path followed by the point xy as x tending to A and y tending to B. The function fxy in the region R is said to tend to the limit L as x tending to A and y tending to B if and only if, corresponding to a positive epsilon, we are expected to find another number delta, which is a positive number, such that 0 less than x minus a the whole square plus y minus b the whole square less than delta square. That is an open disk centered at AB with radius delta. Then fxy more fxy minus L is less than epsilon for every xy in R. As xy approaches AB, if xy approaches the value L. Working rule to find the limit. How will you apply it in the problems? The working rule to find the limit are: step 1, find the value of fxy along x tending to A and y tending to B. Step 2, find the value of fxy along y tending to B and x tending to A. If the values in both two steps remains the same, the limit exists. Otherwise, the limit does not exist. Step 3, if A tending to 0 and B tending to 0, then find the limit along y equal to some mx or y equal to some mx power n. If the value of the limit does not contain m, then the limit exists. If it contains m, then the limit does not exist. We will move on to one problem. F of xy equal to x plus y divided by 2x minus y. Show that limit x tending to 0, limit y tending to 0, f of xy equal to limit y tending to 0, limit x tending to 0, f of xy. How will you do this? Limit x tending to 0, limit y tending to 0, f of x y is x plus y divided by 2x minus y. As y tending to 0, it will become x by 2x. X get cancelled. Limit x tending to 0, 1 by 2, that is 1 by 2 itself. The second case, limit y tending to 0, limit x tending to 0, x plus y divided by 2x minus y, limit y tending to 0, 0 plus y divided by 0 minus y, that's minus 1. Limit of a constant is constant itself. Both values are different, so we can prove that limit x tending to 0, limit y tending to 0 f x y not equal to limit y tending to 0, limit x tending to 0 f of x y. We will move on to the next example. Evaluate limit x tending to 0, y tending to 0, x square y divided by x raised to 4 plus y square. That is limit x tending to 0, y tending to 0, x square y divided by x raised to 4 plus y square. X tends to 0. That is limit y tending to 0, 0 divided by 0 plus y square, which is 0. We again put it limit x tending to 0, y tending to 0, put y equal to 0, then also that's 0. That f1 equal to f2, some f1, some f2. And the third case, we put y equal to some mx. What happens? That also becomes 0. Then we put y equal to some mx square. What happens? Limit x tending to 0, y tending to 0, x square y divided by x raised to 4 plus y square. Put y equal to mx square. We get x square mx square divided by x raised to 4 plus m square into x raised to 4. Taking common, x square x raised to 4 into m divided by x raised to 4 into 1 plus m square. X raised to 4 get cancelled. M divided by 1 plus m square, that is f4. Thus the limit does not exist. Let us move on to the third example. Limit x tending to 0, y tending to 0, x cube plus y cube. Similarly, you can prove this. You have to give y equal to mx square, then only we have found the answer. Similar problems are there. You can do it for practice. Okay, thank you.